Hello, welcome back to our YouTube channel. Today we are going to see Leetcode weekly contest 423 and problem is question number 2, that is adjacent increasing subarrays detection. Okay, so what is given inside this problem? So we have already seen the version 1 of this problem. You can check out the video. So we are given an array nums of n integers and our task is to find the maximum value of k, for which there exist two adjacent subarrays of length k each, such that both subarrays are strictly increasing. Specifically, check if there are two subarrays of length k starting at indices a and b, such that a less than b, where both subarrays are strictly increasing and subarrays must be adjacent. And what is the condition of adjacent? B should be a plus k. So now we need to return the maximum possible value of k. Earlier, in earlier version of problem, so we are given the k and we need to check if it is possible or not. Now we need to calculate the maximum value of k. Okay. So let's first understand the problem. If you have not watched problem 1, and you need to understand. So what is given? So we are given this array. Now we need to calculate the maximum length, right? So what is the maximum possible length? Maximum possible length is, like, let's say if we take this element 7, 8, 9, and then we start taking 2, 3, 4. 2, 3, 4. If you check, 9 and 2 are adjacent. All okay, all good. If they are adjacent, that means this array, this subarray, and this subarray is adjacent. So if they are adjacent and they are increasing as well, if they are increasing, that means length of 3 is possible. Length of 3 is possible. So can we use the same logic as we discussed in the last video? Yes, we can use. So what we will do? We will start from k equal to n by 2. N by 2, we will check for this length. Then minus minus, we will do k minus minus again. And at any point, if it exists, we will return it immediately. That means we got our answer. Right? At that point, we got our answer. And that will be maximum length. But the time complexity is very huge. Like it was n square already for one check, and this is k. So k times we need to check. So n square k, this will be huge. This will not work. In our current example, constants are 10 raised 5. So we need to think something of O of n. Right? So let's try to solve using that approach. Okay. So just absorb. Wait a minute. Okay. So just observe this thing. Like let's say if you are at this point, at the starting points, so what is the increasing subarray? Increasing subarray will be 2, 5, 7, 8 and 9. This is the possible increasing subarray. Okay. So what is the length? What is the length? Length of this is 5. If length of this is 5, can we make it something out of it? Obviously, we can make two adjacent subarrays of length 2. Okay. Whether it can be 2, 5 and 7, 8, or it can be 5, 7 and 8, 9. So length of 2 is possible here. We found out with this subarray we can get off this length. That means whatever is the length, divide by 2. It is possible. It is obviously possible in any case. Now what is the secondary thing? Secondary thing is we need to find the adjacent. Like in current subarray, we know what is the adjacent. How is it possible? But let's say if this is the one sequence Now if it is possible somehow, this is also increasing. That means those lengths will be considered. Okay, so those lengths will be considered, but here can be considered? No. So what is the goal? So let's dry run the solution, you will understand what I am talking about. Okay, let's copy it here. Okay, so let's start from this point I equal to 0 and try to find the longest possible increasing sequence. Not sequence, subarray. Okay, so what is the length of it? Length of it is 2, 5, 7, 8, 9. So we total have 5 elements. Now what will be the answer at this point? We can make 2 subarrays, 2 adjacent subarrays out of it. Obviously we can. So what is the answer till here? 2. Okay, now we know we reached till here. Now we don't need to check anything in this span because that is already covered. Now we need to check everything here. Okay, so we'll start from I equal to 0, 1, 2, 3, 4. Now till 4 is covered, 5. Now we'll cover I equal to 5. Now we'll calculate. Now we will calculate the new length of it. New length. What is the new length? What is the new length? It is 2, 3, 4. 3 length is possible here. 3 length is possible here. Okay. Now, previous length was 5. New length is 3. And they are adjacent. What is the maximum common length? Common length is this 3. And what earlier we have? 2. Right? So 2 and we need to take the maximum out of it. Maximum of L comma NL, that is 5 comma 3, and this will give 3. Now we'll do comparison of this. This is giving 3. So answer will be updated to 3. Now we will not check anything till here because that is already covered. Now we will go here. Now we will get of length 1. Length 1, it will not make any sense to us because we already have of length 3. So we don't need to worry. Go further. Again same thing. Okay. So what we are doing here? We are trying to calculate from the start. We are going, and if something we got, we'll calculate. And what is the possibility? Let's assume this case. So let's say if you have let's say 2, 1, then we have 2, 3, 4, 5, 6. Okay, these are the 6 elements here. This is first one, this is the second adjacent one. Now if you check about what is the answer till here, it is 1, it is 0. So if you want to calculate the minimum of this 2 and maximum of current answer, so the minimum of this is 1 and current is 0. So the maximum answer is here is 0 according to this logic. But if you check this, it is of 6 length. Can we divide it into 2 pieces? Yes, obviously we can divide it into this and this. If we are able to divide, then the length is 3. We got 1, but length is 3. Length is 3. 3 is the maximum possible. So 3 is the K and 3 is the answer. Okay. So now let's go through the code to understand it better. So that's a very straightforward code. So we will calculate the length, initial length of the sequence, the first one. Okay. Okay, so what is the first one? We'll go, starting point for us it is 0 and the nums. Okay, so we'll go start less than nums of size minus 1, because we need to do that many comparisons. Okay, now we need to check if nums of start is less than nums of start plus 1. That means that is a valid sequence. We can increase our length. That element can be we can add that element. So length will be increased, the position will be increased. Okay, so whatever is the length we will return it. So we got our first length. Now what is the answer possible with that length? Length divided by 2, that is possible. And what is the I will be I plus k. Let's say we already got of length 5. Why we will cover this sequence again? This is no sense. So we will directly define the I equal to length. Now we will cover from here only. Okay, so now we want to calculate the new length starting from I. Perfect, we got something with the same logic. Now we need to check what is maximum. Answer equal to max of answer comma new length divided by 2. It is possible na, like old length is only 1 but new length is 10. So we can make of 10 length, we can make two sequence, two subarrays of length 5 each, and both are increasing. So that is the thing we are doing here. And also that we have one thing, and we also need to check from the previous. Like let's say if we got of length 4 only and previous it is there 2. So what is the possible? How many common elements are there? 2 and 4. So we have taken, and length will be updated with the new length, and I will be updated with the new length, I plus length. We don't want to cover anything now. Whatever is covered, we'll go further. We'll check from further. Okay. So what is the time complexity of this solution? So you can see like there is a loop, one loop here and another loop here. The same thing. So you might think it is of n square. No, it's not. Because our iteration, check for this loop. What is the iterating value? We are adding I plus length. So whatever is covered here will not be covered here. Right? So the time complexity of this solution will be O of n only. And what is the space complexity? We are not using any extra space, so it will be O of 1. Okay, if you understood this solution, like this video, subscribe the channel and keep watching, keep coding.